Welcome to the third video for the types of chemical reactions. This one is going to be on combustion reactions and also talking about how to identify which type of reaction you have. I'm going to remind you of the goals for this section. I'm going to define reactants and products, know what a reaction is, know the four states, identify the reaction type, and we're going to try to be able to predict the products. You know what the reactants are, you know what the products are. Remember the reactants, which are the left of the arrow, react to produce the products, and the products are to the right of the arrow. The hallmark of a chemical reaction is what you start with is not what you end up with. The atoms must break bonds and rearrange to make new bonds. Four possible states: solid, liquid, gas, and aqueous. Remember, aqueous is when the reactant dissolves in the water. It's a homogeneous solution, but water is not part of the reaction. We're covering 5 types of chemical reactions: composition, which we've seen, many things becoming one; decomposition, which we've also seen, one thing becoming many; single replacement from the last video, an element and a compound becoming a new element and a new compound; a double replacement reaction, seen in the previous video also; 2 ionic compounds become 2 different ionic compounds; and in this video we're going to cover combustion. A combustion reaction has this generic formula where X and Y will always be greater than 0, and Z can be greater than or equal to 0. So if Z equals 0, then you have CXHY, and we call that a hydrocarbon. If Z is greater than 0, then we have CXHYOZ, that's called a carbohydrate. And so we're going to define a combustion reaction as a hydrocarbon or a carbohydrate that reacts with oxygen, and it will produce carbon dioxide and water. Pictorially, it looks like this. In this case, we have methane reacting with oxygen, and everything rearranges and you get a carbon dioxide and some water. Here we have methanol, CH3OH, plus oxygen becomes carbon dioxide and water. So for combustion reactions, you will always produce carbon dioxide and water, but just because you produce carbon dioxide and water does not mean that it's a combustion reaction. This is along the length of all squares are rectangles, but not all rectangles are squares. I have a quick video of a combustion reaction, but I will warn you right now, you probably want to turn the sound down because I couldn't match the volumes. What you see here is a water bottle that is filled not with water, but with isopropyl alcohol vapors. Isopropyl alcohol is a carbohydrate, and when I ignite it, you see you get the combustion reaction. And just to show what happens is if you take a look in here now, you can see some water, which is one of the products. So now that you know the 5 types of reaction, the question becomes, how do you determine the type of the reaction? And we're going to use a checklist. And the checklist is going to be yes, no, and the reaction type. So the first question, do you have more than one reactant becoming one product? The answer is either yes or no. If the answer is yes, you have a combination reaction. If the answer is no, you go to the next question. Do you have one reactant becoming more than one product? Yes or no. If the answer is yes, you stop, you have a decomposition reaction. If the answer is no, you go to the next question. Do you have one element and one compound becoming a different element and a different compound? Yes or no. If yes, single replacement. If no, on to the next question. Do you have 2 ionic compounds becoming 2 different ionic compounds? Yes or no. If yes, double replacement. If no, go on to the next question. Did you check no on the first 4? If the answer is yes, which it should be if you got to this point, then you have a combustion reaction. If you answer no, you better go back and check because you messed something up somewhere. So for example, we have this reaction. Do we have more than one reactant? Yes, we do. Becoming one product? No, we don't. So this is a no. Do we have one reactant? No, we do not. So we can check no. Do we have one element and one compound? Yes, we do. The titanium 2 bromide and the chlorine gas, compound and element, becoming a different element and a different compound. Now we got titanium 2 chloride and bromine. So this is a yes, and this is a single replacement reaction. We look at this one. Do we have more than one reactant? No, we do not. Do we have one reactant? Yes. Does it become more than one product? Yes. So this is a decomposition reaction. And notice, here water and carbon dioxide are made, but this is not a combustion reaction. Let's take a look at this one. We have more than one reactant becoming one product. No. We got two products. One reactant. No. We have two reactants. One element. Yes. And one compound. Yes. Becoming a different element. There's no single element by itself on the product side, so this is a no. Two ionic compounds. No. Both of the compounds on the reactant side are covalent, so that's a no. Did we check no on the first four? Yes, we did. This is a combustion reaction. More than one reactant? Yes. One product? No. One reactant? No. One element and one compound? No. Two ionic compounds? Yes. Becoming two different ionic compounds? Yes. Double replacement reaction. More than one reactant? Yes. Becoming one product? Yes. This is a composition reaction or a combination reaction. So to review this video, we know that there are 5 types of reactions: composition, decomposition, single replacement, double replacement, and the one we covered in this video, combustion. Combustion is when a hydrocarbon or a carbohydrate reacts with oxygen to produce carbon dioxide and water. This is the generic formula, where x and y are always greater than or equal to 1, and z can be greater than or equal to 0. And if you want to determine the type of reaction you have, use the checklist. Highly recommend you put the checklist on your index card. Here's the checklist, and you check off yes or no in sequence. You stop when you check yes, and that's the type of reaction it is. In the next video, I will show you how to predict various products for different types of reactions.